We'll look at the drive battery. Okay, this is my driving battery, 12.68 volts. Okay. Now we'll look at my bank, which we've put a load onto it to draw the voltage down, so it's not 96 volts. We'll take a look at the voltage on that real quick. Okay, 65.49 volts. Okay, now if we go over here, I'm going to start up the wheel just by giving it a spin, get it going. Oh, you know what? It helps if you hook up your. Okay, a couple things. I'm getting a little anxious and a little ahead of myself here. John Bedini in one of his videos shows that it has a little note that says don't start unless the load is attached, and I think that's why I've been blowing some transistors and stuff, because I'm not the greatest at this stuff yet. I'm trying, but we'll go ahead and connect up our load, which is our 96 volt battery bank. Okay, this wire goes over here to the circuitry. This is my charging output. Minus on top, positive on the bottom. Okay, the top two, minus on top, positive on the bottom, is my driving side. So I will then connect up my driving side to the driving battery, which will allow the wheel to operate. And we're just trying to use a little bit of energy from this 12 volt battery to operate all my switching mechanism. Okay, shouldn't take very much energy to turn those transistors on and off. That's all we're trying to do with it. Okay. Okay, so now the wheel's driving.
So that's the same as a start switch, you turning that manually.
Yeah. So I'll put it on this. It doesn't have a stand on it. I really don't like that one. We'll just leave this up right here. Okay, 12.33 volts on the drive battery, and over here on our charging batteries, you can see them climbing. 6907, 09, 6910, 13, 14, 15, and my wheel is starting to go faster. And if the camera will come around, you can see the little light, the little glowing on the light on the back, which I've been told is important. My new wheel is made of acrylic. It's put onto a set of bearings. You can see that it doesn't spin true because we got errors in our machine work, but it does the purpose. And as we go, getting better at the machining, getting better coils made, getting better with putting the circuitry together, using better parts, we should see improvements and improvements and improvements, which is all exciting to me because we're already seeing positive results from inferior components. And there the voltage is going up. The voltage on the drive battery is down to 12.30.
You're not at optimum speed yet, right?
I don't think so. I'll work on it here a little bit, see if I can. This variable resistor basically acts as your tuning controller, and that's all the way down. Okay, this is all the way up. The circuitry for this whole design is available on the internet through YouTube and through I believe you can get some of it on John Bedini's websites and things like that. I credit most of my stuff that I've done to John Bedini, Thomas Bearden, Stanley Myers, and Nikola Tesla. I haven't invented anything. I'm just trying to duplicate what I've seen and read, and it seems to be working for me.
Can you call this the JF Mark II?
The JF Mark II.
Yeah, your Mark I and you tore apart.
Well, I did tear it apart, but I'll be putting it back together or something. But anyway, Charging batteries at 12.27.
That's not even
Or
dropping.
the driving battery is at 12.27. The charging batteries are at 69.45,
Look at that.
46, 47.
But this, there it goes down a little bit.
And I can actually bring this voltage up by changing the variable resistor. I can make it start going back up. So let's see here. I've gotten some comments, some emails requesting amp readings and things like that. I'm not quite to that point yet, and I apologize for
Doesn't look like it's charging right now.
not providing that sort of thing. But
There it goes.
this way of using this type of energy for its purposes doesn't rely on current. Current's kind of the enemy, and if you read up on Bedini's work and stuff, and Thomas Bearden's work, you might start to understand that. I haven't fully grasped the whole thing yet, but I'm showing you my progress, and we're getting close. I think if you go to the very, very basic principle of what we're trying to do, we're trying to take one small battery and charge a big battery. Use a small battery to charge a big battery, and then use your big batteries to do your work, to do your load. One of the things that I'm not sure about, and I've heard things about, is you don't want to power your load with the batteries that you're charging while they're charging. The idea is to have a second bank of batteries that works your load, and then you switch your batteries that you're charging with your load batteries back and forth so that they're always receiving a charge. And then you can at any time take one of the batteries that you're charging and replace your driving battery. So you make a battery switch. I haven't got to that point either, and when I do, I'll show you. But I told you in past videos that I would try to show you, disclose everything that I was doing, and I'm trying to do that for you.
You can see there's nothing else in this circuit. This is the only components to this entire.
Yeah, there's no. I don't have any capacitors.
Nothing in the back.
No capacitors, no wires, no hidden magnets under the table.
Nothing connected in the back.
On the wheel, we've got some neodymium magnets that are screwed into the top of the wheel, and they're spaced evenly apart from each other, and they're all north pole spacing out. Everything that I've heard and read and stuff says that you want your north pole spacing out. Then as the wheel spins, the magnets come down to the core of the coil and get either repelled or attracted, and then the pulsing turns it on and off, so that the wheel will then spin, and then it turns back on and then attracts or repels the next magnet, and just does that in a repetitive.
So I got a question about the coils themselves. Why are there two coils?
We've got one coil over here, one coil over here. This coil has the what we call the driving wire on it. One wire of the 5 wires that are wrapped around is hooked to the driving circuitry on the circuitry, and is telling it to turn on and off. The rest of the wires on this coil and all the wires on this coil are all pickup wires, sensing wires, that are drawing energy from the magnets passing by the coils. Whenever you have a coil with a core and you pass a magnet through it, that magnetic energy, that magnetic field creates energy. It's like a magneto on a lawnmower.